Welcome to Chemistry at Hononegah High School. I'm Brian Brown, and today we'll be looking at our discussion and furthering our discussion in dealing with significant figures and calculations. Now we're going to look at multiplication division. Now when we multiply or divide, it's the same idea as addition subtraction. Your answer can only be as good as your worst measurement. But how that is determined is different for multiplication division than it is with addition subtraction. And luckily, this is actually a much quicker, easier process for most students to do. Now we're going to round our answer to the same number of significant digits as the measurement with the lowest number of significant digits. So here is a typical problem where we knew two lengths and we're going to be measuring an area. So the length on one side was 238.63 meters. That was our measured value. The length on the other side was 12.0 meters. And we want to calculate the area of that region of space, that rectangle. Well, first thing we do is we plug them into the calculator and multiply. And the calculator is going to spit out 2,863.56. And since it's meters times meters, we know that our final answer is going to be meters squared. Now that's what the calculator says, but that doesn't mean that this answer is the best answer, because I can guarantee the true value is not going to be 2,863.56 plus or minus 0.01. The actual true value based upon the length or the measurements that I've got here is probably a much wider uncertainty than that. So we need to keep our answer accurate, but be as precise as possible. And that means we need to round this number. Now, how do we do that? Well, honestly, all you do is count. The first number has 5 significant digits. All non-zeros all count. So that would be a total of 5 significant digits. But 12.0, 0 on the right, decimal shown, it counts, has 3 significant digits. Well, 3 is smaller than 5. So my worst number here only has 3 digits of significance. So that means I'm going to round my final answer to 3 significant digits. And that's going to guarantee that my answer and its implied precision is going to be accurate. So do just what we looked at a couple of days ago here. So what we're going to do is go to our first non-zero, which is the 2, and then we're going to count over 3 places. 2, 8, 6. We're going to be rounding at the 6. If we round there, we would end up with a number with 3 significant digits. Now, the next digit is a 3. So that tells us that's less than 5. We should round down. So a lot of people look at that and say, okay, 286 is going to be my answer. Now, the problem with 286 is we had 2,863.56, and now we're all of a sudden going to round it all the way down to 286. That doesn't make any sense. Remember, the decimal is there to show us that it's 2 in the thousands place, 8 in the hundreds place, and 6 in the tens place. It still needs to be in the same place. So when you're rounding to the left of the decimal place, you need to make sure you leave a 0, but then don't show the decimal, because that will put the digits in the right column. So 2's in the thousands, 8's in the hundreds, 6's in the tens. And also that 0 is not significant because we did not write the decimal. So I can guarantee you that the actual true value for the area of this rectangle is somewhere around 2,860 plus or minus 10. At that level of precision with this number, I can guarantee that this measurement is going to still be accurate. So that's how you handle multiplication division. Really, it's just count. And the nice thing is you just do the number right in the calculator and you round right out of the calculator face. So let's try a couple here. First one, 5.99 meters times 29 meters. So another instance where we're calculating an area. Well, we're going to get 173.71 meters squared. And that's what the calculator says. But once again, we have to evaluate our measurements to determine what our best rounded answer is. Well, 5.99 has 3 significant digits. 29 has 2. 2 is less than 3. So I need to round to 2 significant digits. So I start at the first non-zero one, count over. The second place would be the 7. So I need to round to the tens column. So I need to take this answer and round at the tens column. Now, next digit is a 3, so I round down. But remember that 7 still needs to be in the tens, and the 1's got to be in the hundreds. So this would be an instance where I'd have to drop that 0 in there to still keep the decimal in the same place. So the best answer, 170 meters squared. Another example, 6 centimeters times 6.0 centimeters. Now your calculator is going to calculate 36, and since it's centimeters times centimeters, we're going to get centimeters squared. But when you look at the two measurements, the first measurement, 6 centimeters, only has 1 significant digit. And the second one, 6.0, has two significant digits. One is less than 2. I have to round 36 centimeters squared to one significant digit, which means I'm going to be rounding at the 3. And since the next digit is a 6, best guess on my answer, 40, which means 40 plus or minus 10. So 40 centimeters squared is how I would report my answer here. And once again, what I'm doing is trying to round so that I can guarantee it's an accurate representation of the area in this particular case. So I can guarantee the true value should be somewhere in between 30 and 50 centimeters squared. And that's what 40 centimeters squared without a decimal point means. Now, division works the exact same way. You literally plug your numbers in the calculator, and it doesn't matter if we're in scientific notation. The process works the same way. So I'm going to put 3.4543 and then hit my EE. Remember, do not hit times 10. That's what the EE key means in your calculator. And then 3. And then I'm going to divide that by 6.02 EE 23. Now, as far as units go, grams and milliliters, they can't cancel. So I need to leave them both in my answer. It's going to be grams per milliliter. Now, when I hit equal in my calculator or execute, it's going to give me 5.7380 and a whole bunch of other numbers times 10 to the negative 21. So that would be my calculator answer. Well, I need to round this to correct significance, so I guarantee my answer is as precise as possible and still remain accurate. So do my evaluation. The first number, and remember, counting in scientific notation, the times 10 part is just placeholder information, so it's not significant. So in the first one, you've got 3.4543. Well, that's got 5 significant digits. So this one has 5 sig figs. And then 6.0 times 10 to the 23rd has 3 sig figs. So I should round my answer to 3 sig figs. So when I count over, that means 1, 2, 3. I'm going to be rounding at the 3. Next digit is an 8, so I round up and I get 5.74 times 10 to the 21st grams per milliliter. So, doesn't matter whether you multiply or divide, you plug the numbers in your calculator appropriately and count your measurements. Now, if we were multiplying by two numbers and then dividing by a fourth number, you would do your multiplication, then you would divide that resulting answer by the other number, and then you would go back and count all of them. If all of them had 3, except for one which only had 2, you're going to round your final answer to 2. So basically just plug them on your calculator, evaluate what's the least significant number of significant digits, and round to that number. And that ends our next set of notes.